Hello students, in this session we'll see how windrows diagram of type 2 will be constructed to determine the best orientation for the runways. So here the image shows the typical windrows diagrams which were drawn to determine the orientation of the runway. You can see here there are some radial lines, concentric circle and some colored area. So here the colored region indicates the wind speed of various intensity. So for example, blue color here in this portion we can see a wind speed of 5.7 to 8.8 meter per second. The wind is of a speed 5.7 to 8.8 meter per second. And similarly, the wind speed from the various direction, which is of different intensity, is represented here in this picture. So now first we'll understand how what all the components of the windrows diagrams and how it will be constructed. So now here this is a windrows diagram example. So now in the windrows diagram, the first constituents when we draw the windrows diagram, first we should draw these radial lines. So all these radial lines indicates the wind direction. So now you can divide the entire 360-degree into required number or required number of division based upon the available data. The one convenient way of division is dividing the entire circle into 16 divisions, each having an angle of 32-degree. Okay, or depending upon the what data available, you can have the number of sectors. And the next components here we have the concentric circles. So all these concentric circles represents the wind direction to some scale. So here the first concentric circle represents a wind duration of 0%. So what is this wind duration? 0%, 5%, that we will look further. So similarly, second line indicates the wind duration of 5%, 10%, 15% and 20% respectively. And here also you can increase the number of concentric circles. So you can have the division and also their scale has to be chosen in such a way that will match with the data available to you. And here this table here shows the typical wind data. So here we can see from the north direction, so total intensity or the percentage of days wind blowing from this direction is 27%. Now how did we got this 27%? For example, we say the north, in the north direction, the wind blowing from the north direction is for a number of days, so total number of days of 38 days in an year. Okay, so I mean to say that from the north direction in the region where we have selected for the airport site, so it says that 38 days the wind is coming from the north direction. If I want to find out the percentage of wind from the north direction, it's very simple, divided by total number of days into 100. So this will gives you the percentage of wind coming from the north direction in that particular site location for in the year of consideration. So similarly, we have to determine from each and every direction how many number of days the wind is expected in that particular direction, and the percentage of wind from each directions will be computed, and it is further used in the windrows diagram to compute the west runway orientation. And next, another important parameters which is required when we determine the runway orientation is the calm period. So now here the calm period is usually when the runway is oriented, we will consider the wind which is having the intensity or velocity of the wind more than 6 kmph. If in case the velocity of wind is less than 6 kmph, that will not interfere with the landing and takeoff operation. Okay, so now the calm period is such duration in the year where the velocity or intensity of the wind is less than 6 kmph, and it will not interfere with any landing and takeoff operation. So now what we have to do is, when we compute the Windrose diagram, we have to neglect those percentage where the intensity of the wind is less than 6%. So for that purpose, in a year, just first check what is the number of days which is having a calm period, okay, and then calculate the percentage of day or percentage of days which is belongs to the calm period. So the total calm period is calculated as 100 minus x percentage. Here x percentage is the number of percentage of wind where the intensity is above 6 kmph, okay, because we will be having, when wind data is collected, only the wind data which is having a intensity more than 6 kmph will be considered. So that value below 6 kmph will not be considered when the wind data is collected. If you want to determine the calm period, so first add all the intensity or percentage of duration where the intensity is more than 6 kmph, and then subtract it with 100, or 100 nothing but the total percentage. That will give the calm period. So we'll look further how the calm period and will be used to determine the west runway orientation. So we'll take up an example. So here you can see that given the following wind data, we have to draw the Windrose diagram and show the best runway orientation, and also we have to calculate the wind coverage for that particular duration. So now here the wind data is given, all the directions, north, north, northeast, northeast, east, northeast, east. Similarly, the 16 directions are given, and in each direction what is the duration of the wind is given. North direction 10.3, north, northeast 8.1. Similarly, in all the direction the values are given. So now and also the total percentage here is 86.5%. Where are the remaining? The remaining is, so here you can see that only the intensity of the wind which is more than 6 kmph is considered here, okay, and the remaining 100 minus the remaining value, that will be the calm period where the intensity of the wind will be less than 6 kmph. Anyways, that has to be considered when we find out the wind coverage, so that we will look further. So what is the first step when we draw the Windrose diagram? So first step is we have to divide the entire circle, okay, into the number of divisions. So now here we have the 16 division. One convenient way is divide the entire circle with angle suspended is 22.5 degree on each side, okay. So like that we will plot all the sectors, and where the naming will be given: north, south, east, west, north, northeast, southwest. First draw the basic directions and then you can divide into the required directions. The next second step is, once the direction is drawn, the next we have to draw the concentric circles. So now when we do the concentric circle, the scale has to be chosen. So what scale we will choose? So for that you have to look what is the maximum percentage. Maximum percentage here is a 14.3. So when I have the 14.3, either you can have a division of 3, 3, 6 and then 9, 12, 15. That can be the one scale. Or I can have, I'll write it here, the first scale can be 3, 6, 9. Each concentric circle having a first start with the 0, 0, 3, 6, 9, and then we can have after that 12 and 15. Or the divisions can also be 4, 8, 12 and 16, or you can also have 5, 10 and 15. Okay, any number of scale you can choose. Concentric circles can be drawn. So now here in the example what you are considering, I am considering the division for every 5, 5, percentage interval. The first concentric circle is for 5%, second for 10, and the third concentric circle is for the 15%. So now it is the Windrose diagram is ready. The next is I have to mark these duration on the Windrose diagram. So how to mark? The first is take each and every direction. First I have it in the north direction. In the north direction, percentage of wind coverage is 10.3. So now what we have to do is from the north direction, so you can see here, this is the line for 10%, 10.3, 10 in between 10 and 15 the wind coverage will be there. Okay, so now in along the north direction between 10 to 15 at the line of 10.3 you mark a point, and once it is done, next check for the north-northeast, that is 8.1. So 8.1 along the north-northeast direction in between the 5 and 10. So in between these two lines my next point has to be located. So north-northeast I have plotted at the 8.1%. And next is northeast 3.9 near to 4, along the northeast 3.9 the mark is plotted. And similarly along each and every direction you have to mark the what is the duration of wind in the each directions. Once all the points are marked, then each and every point on the Windrose diagram that must be connected with the straight line. Okay, just keep on connecting each and every line on the Windrose diagram. So once it is ready, so this portion will determine the total wind coverage in the airport site. Okay, these are the various directions from which wind is expected in the airport site location in that particular year of consideration. Now using this, how to determine the runway orientation? Now within this region or marked region, you have to measure distance between the maximum distance between the any 2 points. So for example, you can check the distance between these 2 points or check the distance between these 2 points or any distance. So now you have to select any 2 points such that you can have maximum distance within the region. Okay, so now in this example I can see that the distance between the points connecting north to south, it is very much higher compared to any other point. So now this is the direction which is best suited for the runway, where we can have the maximum wind coverage in this direction. So hence the runway will be located along the north-south direction. Next is the runway is located along the north-south direction, but we have to check whether the prescribed wind coverage can be achieved with this direction or not. So now to check the wind coverage, what we have to consider is, so first you have to find out, also before that, find out what is the calm period. So now to calculate the calm period, we know the total duration is 86.5%, and the calm period can be calculated as 100 minus the total percentage. So within this, 13.5% is the calm period. So what is the calm period? Where the intensity of wind is less than 6 km, wind is less than 6 kmph, which will not interfere with the landing and takeoff operation. So next is to determine the wind coverage. So we know that the total duration is 85.6%, calm period is 30.5%, and best runway orientation is along the north-south direction. Now to determine the wind coverage on either side of the north-south direction, which direction you comes, now you have to check what is the duration of the wind on those region. So now if I locate the wind runway in north-south direction, it is expected that Okay, it will serve the total wind coverage in this region will be equal to the shaded portion or the region which is highlighted in the green color. Okay, so that will be the wind coverage in that particular direction. So now we have to determine what is the total wind coverage if I locate the runway in the north-south direction. For that purpose, what we will do is, I'll consider the wind coverage from the north direction, wind coverage from the north-northeast direction, north-northeast direction, and then wind coverage from the next is wind coverage for south-southeast direction, wind coverage in the south and south-southwest, and then north-northwest. So now what we have to do, add all these value to determine what am I doing, we are determining the wind coverage. So add all these value plus add the calm period. Since it was not interferes with the landing and takeoff operation, add the calm period. So the cumulative will be how much we got? We got it as 70.5%. But when the wind cover, when the runway has to be, the direction of the runway will be selected in such a way that you must have, ICAO stipulation says that the total wind coverage must be more than 95%. So in this case, the wind coverage is 70.5%, which is less than 90%. Hence, the locating the runway in north-south direction is not desirable. In other way, yes, you can have a runway in the north-south direction, but an additional runway has to be provided such that when it is not possible to use the runway in north-south direction, the other runway which has been constructed can be utilized for during the crosswind components. Clear? So that note you have to write it here. In case of runway will be operation, so here it says that runway will be operation for 70.5% duration in the year, and it will remain in operative for remaining 29.5% duration. So it is indesirable. What we can do is we need to provide one more runway in order to increase the wind coverage above the 95%. Okay, so this is how we can draw the windrows diagram of type 1, and the runway can be located using the orientation of the runway can be located in the using the windrows diagram of type 1. Okay, so in the next class we'll discuss on how the runway orientation can be determined using the windrows diagram of type 2. Thank you.